Hello everybody, hope all of you are well and welcome to this chemistry class. Today I'll continue your biomolecules chapter, and last day we have discussed the carbohydrates. Today I'll start from proteins. So today our topic is proteins. Proteins are highly complex nitrogenous organic polymer with high molecular mass and is obtained by the condensation of alpha amino acid. Now amino acids general formula is like this: NH2CHRCOOH. So this is the general formula of amino acid. Okay, and these are maybe different groups. Okay, and this carbon after this COOH, this one is called alpha carbon. Alpha carbon, and as at alpha position amino group is there, that is why it is called alpha amino acids. And all alpha amino acids except glycine, when R is equal to H, this will be glycine. So all alpha amino acid except glycines have chiral carbon atom. Okay, that means it is optically active and have two optical active isomers. However, all natural occurring amino acids have L configuration. Okay, that means that NH2 group will be at the left side. Okay, suppose if we write the structure of alanine, then you can easily understand that COOH, here will be H and here will be NH2, and at the bottom there will be CH3. So this is the structure of alanine. This is an amino acid. Okay, as NH2 group is in the left side, so this is called L-alanine. Like we can think about the L-glyceraldehyde. If the OH group is the left side, then it is called L-glyceride. Here also in case of amino acid, if the NH2 group is the left side, okay, then it is called L-alanine. And all naturally occurring amino acids having the L configuration, that you have to keep in mind. Next we will discuss the classification of amino acids. Amino acids may be neutral, it may be acidic, or it may be basic. Now what are the neutral amino acids? If the amino acid contains one amine group and only one carboxylic acid group, then it is called neutral amino acid. So neutral amino acid, this one we can tell this means the neutral amino acid. Neutral amino acid. And we can think about also glycine also. Here NH2, one NH2 group is there and one COOH group is there. Okay, so that is why it is called neutral amino acid. Next one is the acidic amino acid. Acidic amino acid means this type of amino acid contains one amine group and two carboxylic acid group. We can give one example like CH3COOH, CH2COOH, and here one NH2 group is there, and this is called aspartic acid. Aspartic acid. So this is also one amino acid. Okay. So this aspartic acid containing two COOH group and one amine group. Okay, so that is why this type of amino acids are called acidic amino acids. So this is neutral, glycine, alanine, and this aspartic acid is called the acidic amino acid. Another amino acid is there, that is called basic amino acid. In case of basic amino acid, there will be two amino group and one carboxylic acid group. Okay, like glycine, there are two amino group is there and one carboxylic acid group. So this type of amino acids are called basic amino acids. Okay, if I draw the structure, you can understand. CH3COOH, CH2 whole 4, and here is one NH2 group, and here is also one NH2 group. This is lysine. So here, as the number of amine group is 2, okay, and number of acid group is 1, so that is why it is called the basic amino acid. So this is basic amino acid. Next we will discuss the nomenclature of the amino acids. Although amino acids can be named according to the IT system, they are generally known by their common names. For example, if I write the glycine amino acid, there is NH2 CH2 COOH. So in this case, so what will be the IPAC name? It will be the amino ethanoic acid. Okay, but its common name is glycine. Its common name is glycine. So this glycine also accepted by IPAC. Okay, and for the sake of simplicity, each amino acid has been assigned and abbreviated, which are generally as the first 3 letters of its common name. Okay, and we can write here, we can take this first 3 letter, we will write GLY, gly. Okay, in case of alanine, you have just written here. Okay, in place of hydrogen there will be one methyl group. So here we can write ALA, ALA. In case of valine, we can write BAL. So in this way we can give their names. Next we will discuss the properties of alpha amino acids, okay, or amino acids. Amino acids are colorless crystalline solids and they are soluble in water, and their aqueous solution is neutral in nature as it contains both one acidic group and one basic group. And in case of if we think about the neutral amino acid, okay, in case of neutral amino acid, there will be one acidic group and another amine group. And what will happen, this type of amino acids, whenever you will take in aqueous solution, they will form some internal salt that is called zeta ions, okay, and which actually form by the migration of the proton, that means H plus, from the acid group to this amine group. If I draw one structure, then you can easily understand. So we are thinking about the neutral amino acids. So this one is C, R, H, COOH, NH2. Now in aqueous solution, what is happening here? This acid proton, okay, that will go to this amine, okay, so it will become NH3 plus and this will form COO minus. Understand? So this is known as zeta ion. This is known as zeta ion, or you can tell it as a dipolar ions. Okay. Now zeta ions reacts both with acid as well as base. Okay. So if we add here base, what will happen? So base will abstract the acidic proton and it will become NH2 CH R COO minus. So that means it is becoming a, in presence of base, that is a anion. Okay. And if we add acid, then what will happen to this zeta ion? If we add acid, definitely it will be protonated. Now this becomes a cation. So this one is one anion and this one is one cation. Now in acidic medium, when an electric current is passed, that positively charged, that means in acid case, this positively charged ion of this amino acid will move towards the cathode. While in basic medium it is an anion, and when electricity is passed, the negatively charged ion of the amino acid moves towards anode. And that intermediate pH, okay, where or when the amino acid has no tendency to move towards any electrode, okay, and exists as a dipolar form, and this is called the isoelectric point. We can give one example that for glycine, when its pH value will be 6.1, okay, then it will not move towards any electrode, and this is called the isoelectric point of the glycine. That will be the 6.1. Hope you can understand. So this isoelectric point is very important in case of amino acids. Okay. Next we will discuss the peptides or polypeptides. Amino acid contains both amine group as well as acid group. Okay, carboxylic acid group. Therefore, two molecules of an amino acids will react to form a amide linkage or self-amide. Okay, we can take the example of glycine, that is NH2 CH2 COOH, and another amine will come, that NH2 CH2 COOH, and there will be elimination of water molecule, and there will be formation of one amide linkage. And this linkage is called peptide linkage or peptide bond. Peptide linkage or peptide bond. Okay, and this is a dipeptide, and if we add another glycine here, so then there will be formation of tripeptide. So we are adding another glycine, NH2 CH2 COOH. So HNN CH2 CO NH CH2 CO NH C double bond O NH CH2 C double H. We have to check here NH2 CH2 COOH, then NH2 CH2 COOH, then one peptide linkage here. Oh, here something is wrong. Here we have to write that this is already done, NH2 CH2 COOH. This one is the another peptide linkage. So here this one is the one glycine unit, this one is the another glycine unit, and this one is the another glycine unit. Okay, so this is called tripeptide, and these linkages are called peptide linkage. Peptide linkages. Okay. Now this tripeptide, here we can write that gly. Okay, that abbreviated form. And the condensation product of the two or more amino acids, okay, of same, it may be same, here we have written same, and it may be different also. Okay, so these alpha amino acids containing that CONH linkage are called peptide. Okay, and relatively shorter peptides are known as oligopeptides, whereas longer peptides are called polypeptides. A peptides having more than 100 amino acids residues and molecular mass is greater than 10,000 is called a protein. Okay, so that means I am telling that if this peptide chain, polypeptide chain containing that 100 amino acids, okay, residue, then it is called protein. But there are some examples, okay, that polypeptides having less number of amino acids molecules are likely to be called proteins if they have a well-defined conformations of a protein such as insulin, which contains that 51 amino acids. Okay. Next we will discuss that peptides and polypeptides on hydrolysis. These peptides, if we hydrolyzed, okay, by acid or base, then there will be formation of again that alpha amino acids, okay, which again we can prepare the polypeptide by condensation reaction. So for the formation of the peptide linkage, the carboxylic acid group is generally changed into a more reactive group like the acid chloride, okay. Then the addition of the amine to forming this peptide linkage will be very easier. Each polypeptide chain has a free amine group at the one end, okay, and another end there will be the COOH group in the other end. The amine group, that amine group end, okay, this end is called the N terminal. This is called N terminal. And this COOH group, that this side, this is called the C terminal. C terminal of a polypeptide chain. Okay. And the structure of this polypeptide chain, okay, polypeptides is generally written in N terminal, okay, at the left and this C terminal at the right side. That you have to remember. Okay. Suppose here I can show you different types of amino acid this polypeptide linkage, then you can easily understand, like glycine, alanine and serine. Glycine, plus alanine and another is serine. Then if we form this linkage, peptide linkage, then it will be like this. So this is one amide linkage and this is another amide linkage, okay. And this can be, this one is the glycine, this one is the alanine and this one is the serine. So here it can be abbreviated as gly, ala and serine. Hope you can understand. And this is a tripeptide, okay. And we can give the name of polypeptide chains in the abbreviated form also. Okay, that is very important. Next we will discuss the classification of protein. On the basis of the molecular structure, proteins can be classified into two categories. One is fibrous protein, another is globular protein. Okay, now what are the fibrous protein? The proteins which consist of linear thread-like molecules which are arranged side by side or twisted to form fibers are known as fibrous protein. And these polypeptide chains in the fibrous protein are held together by hydrogen bonds, intermolecular hydrogen bonds, okay. And these proteins are generally insoluble in water and are stable to small change in pH and temperature. We can think about the examples of keratin in skin, hair and nails, and myosin in muscles, etc. And in case of globular proteins, the proteins in which the polypeptide chains are folded into spheroidal shape and are called globular proteins. And these polypeptide chains in globular proteins are also held together by hydrogen bond, and which is comparatively weaker due to the small area of contact. And next one is that globular proteins are water soluble and very sensitive to change in the pH and temperature. And examples we can tell about that hemoglobin, okay, proteins, albumins, antibodies, hormones, etc. Okay, so today up to this. Next day we will discuss the different types of structures of proteins and then enzymes. Okay, then vitamins are not in your syllabus, then we will go to the DNA RNA structures. So today up to this, thank you.